All right, guys, let's go over the stuff for our pneumatics review. So these are the topics that I want you to cover. We're going to cover all of those within this review. So I want you to know the 3-2, the 5-2. Now, you're not going to have to actually draw out these diagrams. I used to have you draw out the diagrams. Everything on this test is actually going to be multiple choice. That doesn't mean that it's easy, though. You'll see that similar to the review, it starts off fairly simple, covering components like this, the 3-2, 5-2, manually versus pneumatically operated, single acting versus double acting cylinder, and two pressure in the ore shuttle valve and the wind wave flow control valve. Those are all the components we're going to use. So I'll ask you basic questions on each of those components. Then we'll start off with some fairly simple diagrams, and then at the end of the test, like the tail end of the test, it's going to be disgustingly hard circuits that we're going to go through. So just keep in mind when you're leaving the test and you're cursing me and my family 5 generations back, that the hard portion of the test, like the really difficult portion of the test, is about 30% of the marks, right? So it's there to challenge you guys at the back end, not to frustrate you. Okay, so on this handout, it will have the questions and then it'll have the answers on the next page here. Okay, so I'll go through everything here, and then as you're taking notes, you can add to this page right here. Okay, so first thing we'll do is we're going to cover like a 3-2, right? So I'll ask you, what is this, right? So I'll have this component right here, and I'll say, what is this? This is a 3-2, a 2-2, a 5-2. So this one we know is a 3-2 in that it has 3 ports and 2 positions. Okay, the 2 positions are here, right? This blue box right here is one position of the switch, and then the other position of the switch is this guy right here. Okay, the other thing that I might ask you would be, what's the rest state of this unit? Is it normally open or normally closed to the passage of air? And keep in mind that pneumatics is asked backwards from the way that we learned relay logic, in that this unit right here is acting as a normally open contact, right? A normally open electrically, right? So it's acting as this electrically, but we can see here that it is a normally closed to the passage of air, right? So this was normally closed, and that's to the passage of air. Okay, you can see there that that T is blocking the source there. Okay, then if we take a look at the ports, then the 3 ports for this guy would be 1, 2, and 3. So we got 1 being our supply. Then we got 2 going to the actuator. Those are the ones that we hook up, right? Where we're doing these in the lab, we're going in on the left and out on the right. And then 3 is going to be the exhaust. 3 you don't have to hook up whatsoever. It is integral to the actual unit there. Okay, what else could I ask you on here? The other thing I could ask you would be like the rest state for the switch. Well, rest state is denoted by the spring. Okay, so whatever side, this blue side right here, is connected to the spring, so whatever side the spring is connected to, that's going to be your rest state for this unit. Okay, the red side is going to be the activated side. The red side corresponds to when we press the actual push button there. Okay, and aside from that, the only other component that we have here is the single acting cylinder. So I may ask you this one right here, saying, is 1A1 a single or a double acting cylinder? Right, so nice, easy questions to start off, lulling you into the fact that it's going to be an easy test. Okay, so everything's there. Let's see if I missed anything on this page. The only thing I missed there would be like the sequence of events here. So if I ask you what the rest state is for the cylinder, then 99.9% of the time, the cylinder is going to be in the retracted position. Okay, so with this one, once we press the push button, then air will be able to go up, right? Push against the cylinder, extend the cylinder, and then once we let go of the push button, then the rest state of the unit comes in, right? In that this side would then be active with the spring, and any air that was in the cylinder is going to come out and exhaust out of port number 3. Okay, so hopefully everybody's cool on this guy. Okay, so starting off nice and slow. Then the next page is a 5.2, right? So a 5.2 has 5 ports and 2 positions. All right, so the 5 ports, we have number 1 being our supply. All right, so these are identical to a 3.2. Number 2 is going to the actuator. Now remember, this is a multiple choice test, right? So I may say actuator A, right, just to denote that's going to one side of the unit, right? Or I may say that in that case it's going to the retract, right? So I may say actuator retract there. Okay, then we have 3, so 3 is the exhaust. So that's where I may say, like, that's exhaust A, right? Because that's our first exhaust that we're looking at. Then 4, I may say actuator B, right? Or I may say, in this case, then it is the extend signal to the actuator. So that was this bad boy right here. And then finally, number 5 is another exhaust. So these 5.2s have 2 exhaust ports, one being 3, one being 5. And again, to show that if it's multiple choice, I may say exhaust B there. Okay, so again, we don't have to draw this out, but you wouldn't have any issue if I asked you to draw out a 5.2, right? Because we've done this so many times in class there. The 2 positions for the unit, let me just look at the color coding. What did I use? So I used blue for the home position. So our rest position is going to be denoted by the spring, right? So the spring is against this box right here. So that's our rest position. Okay, and again, if we follow that, then air is coming up and pushing back on the cylinder, so it's causing the cylinder to retract. So again, if I asked you for this one for rest position, the double acting cylinder would be in the rest position. So this guy, different from the previous one, is a double acting cylinder, in that it has 2 ports, right? One for retract and one for extend. Okay, and then our active side is with the push button. We don't have any 5.2 push buttons in the shop yet, but similar to the pneumatically controlled units that we were looking at. Okay, aside from that, what else have we got? We got this guy right here. So this is different than, or in addition to other units that we've looked at. This one is an FLR. I guess it rolls off the tongue a little bit easier with FLR rather than FRL. That is a filter. Then the next thing in line would be a regulator, but they're saying lubricator and regulator. So in effect, the filter and regulator are usually part of the same unit, and then a lubricator would just be beside. So the air filter is to get rid of any impurities in the air. Obviously the regulator is there to control our pressure, and lubricator works on the Venturi effect, in that as the air passes by, there's a small container of oil, and then little tiny particles of oil get mixed in with the lines there. In the shop, we've chosen not to use a lubricator, so a lot of our, like at the back of the room, our lines have quite a bit of rust, but we opted not to use the lubricator because if any condensation happened in our lines, that little oil and any type of moisture will cause like a white gunk to happen within the components there. So we'd rather have a little bit of rust than that white residue that causes with the lubricator. So, but this one is our FLR, filter, lubricator, regulator. Obviously the lubricator is not shown, but this is kind of showing our filter, and this is denoting our regulator. This one here is just our standard signal or symbol for our air supply there. Okay, so let's look at the answers here, see if I missed anything. I think we're good. Okay. On our next one here, so this is example number 3, we have 2 examples here. So one here has 1S1, so if we press 1S1, this is a 3.2. right? This is also a 3-2 up here, so that's a pneumatically controlled. Again, we don't have a 3-2 pneumatically controlled in the shop. This one is normally closed to the passage of air, so rest state would be the cylinder would be retracted. If I press this 3-2, I send a signal into this pneumatically controlled 3-2, then air will be able to go up through here, because that'll be the active side, and that'll cause this unit to extend. If I let go of the push button, then this is no longer the active state. We're looking at the spring, so the spring would then take over, right? This would be the side denoting with the spring, and so this signal is lost, and so any air that was in the single acting cylinder is going to exhaust out of port number 3. Okay, looking at this one on the other side, we have a 3-2 that is controlling a 5-2. Okay, so this is a form of indirect control in that we have a push button controlling a 5-2. The 5-2 then controls, in this case, a double acting cylinder. On our examples, we had a separate air supply here, right? So we had this supply at 20 psi, and we had this supply at 100 psi, in that a smaller pressure could control a larger pressure. In this case, they have the exact same pressure going to either component. So that 3-2 is controlling the 5-2, and again, if I press this push button, then air will come up, go over to here, it will activate this 5-2 pneumatically controlled unit. Air is sitting at port number 1, and it will now go to the active state, so we'll do that in red here, right? So active state was here. Active state over here, we have the air coming to port number 1, then air will come up, it will go to port number 4, cause this to extend, and any air that was in the double acting cylinder will come down and exhaust out of port number 3. So they don't show these ports, but this is 1, 2, this is 3, 4, and 5, right? This 5 denotes this guy right here, and this 4 denotes this guy right here. Okay, if I let go of that push button, then the spring takes over on this guy. So if the spring takes over on this unit, then air is available here, but it's blocked here. So no air is getting to here. The signal is then lost to the 5-2. Let's get rid of all these guys. Okay, so signal is lost to the 5-2, so no longer any air to here. So then we're back to the spring. So that will take over and air will come up, go to port number 2, push back on the cylinder, and any air that was in the cylinder will exhaust out of port number 5. Okay, so slowly building up with, like I've already asked you, components on the 3-2, the 5-2, the ports for each one, rest state for the cylinder, what this symbol denotes, right? That again is our FLR, filter, lubricator, and regulator. I've asked you about the spring and that it denotes the rest state. And I've asked you whether a 3-2 is normally open or normally closed. And we can see here that this one is normally closed to the passage of air. Okay, so we're building up marks there, building up our confidence. Okay, answers are here. Okay, and now we're on to the next one. So there's an issue with this circuit. So take a couple seconds and look at the push buttons. The issue is with the push buttons. So this was similar to lab number 3. So the issue with this guy is that if I press 1S1, right, then that side will be active. So this side will be active on the unit. Then air will come up. It will definitely come over here and actuate this 5-2 pneumatically controlled unit. And then air will come up, come over here, cause this to extend, and then the air will be able to exhaust out of port number 5. So that's all good. The issue is that right here I have a T, right? So for here, the air will be able to come out and exhaust out of port number 3 of the opposite switch there. So in this case, the logic that's drawn here is an OR, right? 1S1 or 1S2 are to be pressed, and that's to actuate 1V1 being the 5-2 pneumatically operated relay. So with this guy, we got to put in a shuttle valve, right? So it's missing this bad boy right here, and that would be our OR logic. So when the so when this 1s1 is pressed, then this ball right here will move over to this side right here, and then the air will be able to come up, actuate the 5-2, but block any air from exhausting out of port number 3 on the opposing switch there. Okay, let's take a look at example number 5. Okay, we're rocking along here. We've got the addition of a limit switch now. So we've got a limit switch at the top here. So this one is our 1B1 limit switch, and that is our extend limit switch. Right, in that when this one extends, it's going to trip off 1B1. So we can put here, this is our extend limit switch. You'll see that in line with the push buttons, that's where we have the limit switch, right? So the way that these guys are usually drawn out, in that we have all of our 3 2s in line here. Then we have our logic, right, being our AND or OR valves. Then if we were going to have a timer, our timer could go in here, right? Then we've got our 5 2s here. Okay, so 5 2s would be in a line here. And then if we were going to have any speed control, it would be in line with our actuator. So you can see there that by putting the 3 2s in the bottom here and having this guy down here, then it cleans up the diagram in that you don't have too many lines that are crossing over each other. Okay, so let's take a look at the logic on this guy. So on this unit right here, we've got an OR valve, right? So that is our shuttle valve. So 1V1 is, I would ask you, because that's the first time that we've seen this diagram in the test review. So this one is our OR valve. It's also called a shuttle valve. Okay, so it looks like the logic here is that 1S1 or 1S2 is to be pressed. That will send air. So if I press 1S1, then air will be able to come over here. This ball will move over to here, blocking the air from exhausting out of the other switch. That air will come up to this pneumatically controlled 5-2. It will actuate this side. That triangle corresponds to the left-hand side of the 5-2. And air is supplied to terminal number 1. That's going to go up to 4, cause this to extend, and air will come out down to here to terminal number 2 and exhaust out of port number 3, causing this guy to extend. Once that guy has extended, then it's going to hit 1B1. But the trick to this guy is that if I'm still holding 1S1 or 1S2, then this signal right here will not be able to come in. Right? At this point, 1B1 is actuated, so air is coming up to here, right? But the 5-2, it's equal pressures, right? So the 5-2 already had the signal on this side, so this signal right here can't come in until we eliminate this one right here. So in this case, 1S1 or 1S2 have to be pressed in order for it to extend, but we can't hold on to, or we can't keep pressing 1S1 or 1S2, otherwise the limit switch will not be able to allow it to retract. Okay, if I let go of 1S1 or 1S2, then this air is then blocked on this side, right? No longer having the signal on that side. So then at that point, the air can actually come in on this side, actuate this side of the 5-2. That corresponds to this box right here. So once the limit switch actuates that side, then air is available at port number 1. It's going to go up to port number 2 and obviously cause the double acting cylinder to retract, right? Because we got air to here. Any air that is in the cylinder is going to be able to come out and exhaust out of port number 5. Okay, so logic on this one is 1S1 or 1S2 is pressed, causing the cylinder to extend. And as long as we have let go of 1S1 or 1S2, then the extend limit switch is tripped, and at that point the unit will retract automatically. Okay, so hopefully that covers the basics on this guy. The only new component that we had was this guy right here, being our OR valve or the shuttle valve. Oh, we also saw that limit switches are found usually on the bottom of the diagram here. Okay, so did we cover everything there? Looks good. Okay, so now we're into this guy right here. So this one gets a little bit more complicated. Can I zoom in on this? Let me just get this on the screen. Okay, so below all we have is just our supply down here. So for this one, maybe first question would be on these speed controls here. So the martini glasses are drawn like this. And so again, rest state is that air is coming up and it's pushing back on the cylinder. So rest state is that the cylinder is in the retracted position. But the question I would ask you, in that this is the first time that these speed controls have been shown in the diagrams, I would ask you which one is for the extend and which one is for the retract. So if air is coming up to here and causing this to extend, then that air will come down. It will seat this ball, and then the air will have to go through the flow restrictor. So for this side, 1V5 is actually the extend speed control. So you'll find that the speed control is often placed into the opposing line, right? It's not in the supply line, it's in the line that has the air exhausting out. Okay, and that means that on this side, this is going to be our retract speed control. Okay, in that if air is going into here, causing this to retract, that air that was in the cylinder will have to come down. Again, it will seat this ball, causing the air to go through the flow restrictor there. Okay, so you can place them in the supply lines if we were going to. It's just the fact that most times the diagrams are shown in that the speed control is shown in the exhaust. If we were to put these in the supply lines, then those two martini glasses would have to be drawn like this, right? So our speed controls would have to be 180 degrees from where they are right now. Okay, so make sure that you're cool on determining whether a speed control is either doing the extend or the retract, right? In terms of signals, this is our extend signal and this is our retract signal, right? So they're in the opposing line for our speed control. Okay, here we have a 5-2 here, and it looks like we got a bunch of 3-2s, 3-2, 3-2. We got an OR logic here, and we got another 3-2 down here. Okay, so the next question I would ask you on this circuit is which one is the start push button? So for that, you may want to reverse engineer it, or it may be intuitive in that this one is the first one in line. So this one right here is our start push button. So you can do two things. You can reverse engineer it in that this has to extend, so that means that this side of the 5-2 has to be actuated, which means that this signal has to be coming in, which means that there must be air here, which means that this guy must be actuated as well, which means that there must be a signal over here, which means that this is not pressed, right, because air is coming up through here, and it means that this one, 1S1, must be pressed in order for air to extend up. So that's the way that I usually determine which one is my start push button. I start at this signal right here and say, all right, in order for that to happen, then what sequence of events has to occur there? So hopefully you can see here that if we walk through this, if I press this start push button, then air will travel up. This ball will move over. Air will move up here to 1S2. As long as I don't press 1S2, that air will come up to 1V2. This is a 3-2 pneumatically operated valve. That air will come up, come through here, and come up over to 1V3, causing this side of 1V3 to be actuated. Then the air will come up and go to the double acting cylinder and cause it to extend, but cause it to extend slowly. And any air that was in there is going to come down to here and exhaust at a port number 3. Okay, so hopefully everybody's cool there. One thing you may have noticed as we went through there is that there's an additional line right here. So there's a T here, and then this guy comes down, easy now, this guy comes down here, and then that goes to this unit right here, causes that ball to move over. Sorry, it's bugging me that it's not in line, but my pen is not working with me. That's a little bit better. Okay, so air will come to here, and then air will be going to this unit right here, as long as we don't hit 1s2 there. So the trick with this guy is that it backfeeds into the circuit here, and so this purple portion right here is similar to, like, the whole circuit is similar to this, right? In that we're going to have a stop push button. So normally electrically we have a normally closed stop push button, and then we have a normally open start push button. That purple portion corresponds to the holding contact that goes to or goes in parallel with our initiating start push button. Okay, so by pressing 1s1, then the air will move this ball over, go through 1s2, actuate 1v2, then on this purple portion here with this T, then it backfeeds into the circuit, pushes this ball over on the shuttle valve, and keeps air being applied to 1v2. As air is applied to 1v2, then that air will be able to keep coming up to here and keep 1v3 actuated there. So the purple portion of the circuit corresponds to this portion of our electrical circuit. Okay, if we're looking at like the logic here, 1s1, which is our start push button, is actually a normally closed, corresponding to an electrically normally open. Our stop push button, which is going to be this guy right here, so 1s2 is going to be our stop push button. That one is a normally open, right? Normally open to the passage of air, but electrically it would be normally closed. So pneumatic switches are usually the exact opposite of what an electrical switch would be. Okay, so if we press that stop push button, then what's going to happen? We're going to press this guy right here, which means that this is true, which means that this side of the stop push button then comes into play. So if that happens, then we no longer have air being applied to 1v2, so this disappears, right? So now we're back to our rest state, so the spring would take over on this guy. Air would be blocked at this portion right here. That means that this disappears, right? So that loop there of air backfeeding disappears. This signal disappears on 1v3. So 1v3 then goes back to its rest state. And if 1v3 goes back to its rest state, then air will come up, cause this to retract, and cause it to retract slowly because, again, we have speed control on that line, and the air that was in the double acting cylinder will exhaust out of port number 5 there. So this one is corresponding to our standard 3-wire control that we'd see electrically, and it has this cool portion of the circuit right here that allows for backfeeding into the control circuit. My pen is not working very well at the moment, corresponding to the holding contact in that circuit there. Okay, so getting a little bit progressively harder, but not, outside of the realms of figuring out the circuit there. So during the test, you're also going to be provided with large paper diagrams where you can walk through with the pencil, going through the logic and taking notes just like I did here. Okay, anything missing that we covered? No, I think we're good. Okay, so let's take a look at this circuit here. So again, below is just the air supply down here. So I'm going to keep it like this so we can see the whole circuit. Let's start off with our speed controls here. So these martini glasses are drawn like this. So let's see, if this extends, that's going to seat this ball and have to go through the flow restrictor. So 1v6 is actually my extend speed control. Right, that's my retract signal. This is my extend signal. And in the opposite line if air was to go like this, right, retract, that air would come down, seat this ball, and have to go through the flow restrictor. So this one here is my retract speed control. Okay, so that takes care of the two speed controls, in that if I ask you any questions on those guys, if I asked you a question on rest state of the double acting cylinder, as always, that would be in the retracted position. Okay, any air that was there would be going through here. This line right here, number 1, comes all the way down through here and tees onto our supply, which is right here. Okay, let's take a look at the logic on this guy. Before we actually look at the logic, let's take a look at our limit switches. So we have 1B1, which is right here. 1B1 would be our retract, 1B2 would be our extend limit switches. Those guys are integral to the actual double acting cylinder, in that they're most likely reed switches that are mounted on the top of the unit, and as the magnet on the inside passes by, it's going to close those contacts. Because those are electrical limit switches versus the mechanical switches that we saw above, right? So mechanical limit switch was drawn like this, right, versus our electrical limit switch, which has the star here. Okay, so here we're denoting a limit switch, and it's just electrically, right? It's electrically connected to this unit here. So 1B1 is, let's see, 1B1 was our retract limit switch. Okay, and then 1B2 was our extend limit switch. Okay, we have components here for logic. So we have 2 AND valves. The name for that guy is a 2 pressure valve, in that it has to have equal pressure on either side in order for the air to come up and extend out of this unit. Okay, for that guy, for the 2 pressure valve, if we only had air on one side, right, so if we only had air on this side, then it would block the air from exhausting out of the output. If we had the same thing but with air on this side, then it would block air from exhausting out of the unit. We have to have basically equal pressures on either side in order for the air to go up and come out of the output. Okay, so that's our 2 pressure valve, providing us with our AND logic there. And then looks like we have an OR valve as well, right? So there's an OR valve right here. Okay, I think on the answer sheet that is incorrect. So let's just quickly check the answer sheet. Get rid of this because we've already covered that. Yeah, this one here is an AND valve. Okay, so you can adjust that. Okay, so let's take a look at this guy. So for this one, in order for the unit to extend, so again, let's reverse engineer this, right? So this guy here is our rest state, right? So we'll do our rest state in blue. Okay, actuated state is going to be in red here. Okay, so for this one, we would have to have air coming into here, which means that we'd have to have air from here. That means that we have to have air on either side of these guys. So that means that we have to have air coming in from this guy. So that means that the retract limit switch, which in this case is shown in the actuated state, right? So careful with this one, in that on all the other diagrams, everything was shown in the rest state, whereas this one is shown in the actuated state, in that the limit switch here, right, so this guy right here, is actuated because the double acting cylinder is in the retracted position at the moment. Okay, so normally the spring denotes the rest state, but in this case it is sitting with the cylinder at the retracted position, which means that this limit switch is actually true. Okay, so in order for it to extend, we have to be in the home position, right? We have to be in the retracted position in order for this air to come up here. And what else has to happen? The other thing that has to happen is that if we have air coming from here, that means that either push button, 1S1 or 1S2, has to be pressed. So hopefully everybody's cool and that you can see that push button 1S1 or 1S2 has to be pressed, and the double acting cylinder has to be in the retracted position in order for this to extend. And obviously it's going to extend slowly because we have speed control 1V6 in that line there. Okay, once it extends, it's then going to trip 1B2. If we're looking at logic here, that is no longer in the retracted position, so there's no longer air at this side, right, which means that there's no longer air being applied to that side of 1V4. So at that point, we have 1B2 that is then tripped, right? So then 1B2 is true. That means that air comes up here, and comes to this guy. But it gets to this AND logic component, so we also have to have something else happen at the same time. So once it extends, 1B2 is definitely tripped because that limit switch, the magnet has gone across the reed switch and sent the signal in. But the other thing that has to happen is this line right here has to be true, right? So this has to be true, and this has to be true. So it won't retract right away. We're going to have to hit 1S1 or 1S2 in order for this signal to come in here. So logic here is that 1S1 or 1S2 is pressed, and the double acting cylinder is in the retracted position. That will cause this unit to extend. It will then hit 1B2, and this will be true, but we will have to wait for somebody to press either push button. When either push button is pressed, then we have this side true, which means that air comes out of here, actuates this side of the 5-2, and causes the unit to then retract. Okay, once it retracts, then we have a retract limit switch that's true again, and then we can start the cycle again. Okay, so hopefully everybody's cool and that 1S1 or 1S2 is pressed and the double acting cylinder is in the retracted position. Then the double acting cylinder extends, stays extended until we press 1S1 or 1S2 in order for it to retract. Okay, so hopefully everybody's cool on this one. What are we at? Example number 7. We're rocking along. All the answers are provided here. Make sure you change this to an AND valve. And we'll move on to example number 8. Okay, so looking at example number 8, below here we just have the supply, but I'm going to move it up so that we can see most of the circuit here. Let's start off with our speed controls. So it looks like speed controls are drawn like this, and this martini glass is drawn like this. So let's see, if I have air coming up here, it's going to seat this ball, have to go through the flow restrictor, and then slowly extend 1A1. So this 1V3 is my extend speed control. Okay, so hopefully you got that one correct. On the other side, this is my extend signal, this is my retract signal. I have speed control in the retract side, so this is most likely an extend speed control. But let's take a look. Air would come up here, extend this double acting cylinder. Any air that was in the double acting cylinder would then seat this ball, have to go through the flow restrictor. So for sure, 2V2 is also an extend speed control. Okay, so hopefully you can see both of those. Rest state for these guys looks like this is blocked, right? So the rest state for the 1A1 single acting cylinder will be in the retracted position, and it looks like this side of my 5-2 is the rest state. So again, that guy is also going to be in the retracted position. So again, 99.9% of the time, the retracted position for all valves are going to be in the retracted position there. Okay, let's take a look at limit switches now. So we've got 1B2. So this is 1A1 extend, right? So 1B2 is right here, so that's 1A1 extend. And then we've got 2B1, so that is 2A1 retracted. And then 2B2 is 2A1 extended. So let's see, 2B1 is 2A1 retracted. And then 2B2, which corresponds to this guy right here, is 2A1, the double acting cylinder, extended. Okay, and those are our limit switches. This one looks like a physical limit switch, whereas this one are reed switches that are mounted on the outer casing of the double acting cylinder there. Okay, let's look at logic now, guys. So let's look at when we press this push button. There's only one push button in the circuit, so that's our start circuit. That is going to have air come up here. That's going to go to this guy. This is an AND or two pressure valve. So we've got a signal here, but we also have to have a signal on this side. So we have to press 1S1 push button, and something has to be true over on this side. So the thing that has to be true is that 2A1 has to be retracted. So the double acting cylinder has to be in the retracted position. Then we can press 1S1. Then the signal will be able to come up to here to 1V2. Once that comes to 1V2, then this side of the unit is true. Then air will come up, seat this ball, and extend the single acting cylinder in a slow fashion. Okay, once that single, well, let's write that down because that was the first thing that happened, right? So first thing that logic that happened was that 1A1 went out. Okay, once 1A1 goes out, then it then trips 1B2, right? So 1B2 is now true. So 1B true is now true, so that means air comes up here and goes through this limit switch, comes up here, and then has air going to this 5-2, 2V1, right? So this is true now. And on this side we had this signal being true, okay? And so at that point, that corresponds to this box on the 5-2. That means that air comes from port number 1, goes up here to port number 4, and again causes 2A1 to extend. So the next thing that happens is that the double acting cylinder is going to extend. Now the question is, which one retracts first? Does a single acting cylinder 1A1 or does the double acting cylinder 2A1 retract first? Well, that all depends on these signals here, because we have to eliminate those signals before the unit can actually retract. Okay, so at that point, let's do another color here. At that point, 2B2 is then true, right? 2B1 is no longer true, right? So, is that right? Yeah, because this moved to here, right? So 2B1 is no longer true. Okay, is that correct? Yeah, so that means that this is no longer there, and that signal then disappeared. Okay, so then 2B2 is then true, right? Because that has extended now and hit this limit switch 2B2. So 2B2 is then true. That corresponds to this side of that limit switch. So air is going to come up, come over to here, and come to here. So that's true, but we haven't eliminated this side, the left-hand side signal yet, right? So we need to eliminate this before this purple signal can come in. Okay, in order to do that, then we have this T right here. So air is also going to come over to here, right? We eliminated this signal. So now this is true, which corresponds to this side. So that means that air is blocked. So air is no longer here. So at that point, the single acting cylinder is going to retract. So it looks like our next one is that 1A1 is going to retract. Okay, once 1A1 retracts, then what happens? So 1A1 retracts, so then this is no longer true, right? Which means that these guys no longer have any air. This is no longer true. So now the signal from 2B2 can then come in, right? So now this guy can come in. That corresponds to this side of the 5-2. So now air will be able to come up and cause this guy to retract. Cool, looks good. So last thing is that obviously the last thing is 2A1 is going to retract. So in this case we have the logic in that 1S1 and the double acting cylinders in the retracted position. That signal comes up here to 1V2, causes 1A1 to extend. Once 1A1 extends, it trips 1B2. 1B2 is here, which causes air to come up, go to this 5-2, which causes the air to come up here and extend the double acting cylinder 2A1. Once 2A1 has extended, then 2B2 is tripped. That signal comes in here, but the signal on this side, the left-hand side, was still there, so that air also travels over here to this pneumatically controlled 3-2, which causes 1A1 to retract. Once 1A1 retracts, then 1B2 is no longer true, so this signal disappears, this signal can come in, and then air will come up and cause 2A1 to then retract. So a little bit more complicated, right? You can see the 4 different colors that we've used here, but in terms of the answer, remember it's going to be multiple choice, right? So the multiple choice answer will look like this. So once you've done all that time and effort in order to find the right answer, then watch for dyslexia, right? You want to make sure that when you look at the answer, you're like, okay, 1A1 goes out, then 2A1 goes out, 1A1 goes back, then 2A1 goes back, right? Because there's going to be 4 answers with minor variations, well, 1 variation on each one, right? So make sure that you get the appropriate answer and watch out for dyslexia. You never know when it's going to hit. Okay, so that takes care of example number 8, getting a little bit more complicated here. Let's take a look at example number 9. So you can see here that that's the sequence there. Okay, if you guys were doing this in class, I most likely, I may not have gone through that one. So your answer is there for that one. Let's take a look at this guy now. So example number 9. Number 9 has a new component here. So we can see here that we have a timer. So this is drawn like this, right? We have our tank here. So that's our holding tank. So for this guy, the question that I would ask you would be, is that an on delay or an off delay timer? So taking a look at this guy, if air was coming into here, it would seat that ball and have to go through the flow restrictor when air is flowing in this direction, right? So that means that air would slowly build up in the tank, right? So pressure would slowly build up in the tank, and it would have to go greater than the spring. I don't know, the spring's probably good for about 20 psi, right? So once this guy gets to a little bit higher pressure than the spring, then it's going to cause this unit to actually move over. So that timer there is an on delay timer. Okay, so first question would be, what is that component, right? And then next question would be, what type of timer is it? In this case, this is an on delay timer. Okay, on delay timer is similar to an RC timer, right? So we have an RC timer, and then we're taking voltage off of that capacitive component, right? So this is our resistive component, and this is our capacitive component. Slowly allowing pressure to build inside the capacitor or inside the tank, and then once that pressure is greater than the spring, then it can move on. Okay, the speed controls look like they are drawn backwards from the opposite or the other diagrams, but let's see what they control now. So if I have air coming up here, then that's going to seat this ball and have to go through the flow restrictor. Okay, so this is my extend signal, this is my retract signal. 1.01 is actually an extend speed control. Okay, so be careful on this guy. I will most likely give you the speed control drawn like the other ones were. This one is a little bit, well, this one is the opposite. So this one here is going to be our retract speed control. Okay, in that if air is coming up here, it will seat this ball and have to go through the flow restrictor, so air flowing in this direction will be slowed, and that's our retract signal. Okay, we have a 5-2, we've got an AND logic here. We've already covered the timer there. Just watch that in that it looks like 1.4. 1.4 is our retract limit switch versus 1.3, which is our extend limit switch. So we can put here that 1.4 is our retract limit switch, and 1.3 is our extend limit switch. So a couple of things here. This line continues on. That nomenclature 1.3 is covering that line, but that line goes up to number 1 on our 5.2, and you can see that 1.4 is in the actuated state, right? The spring is here denoting rest state, but we can see that it is in the retracted position. So in that case, the 1.4 would then be tripped. So it's just showing you that that it's actually being actuated at this point. Okay, looking at our logic here for the first point, if we press 1.2, our push button, then that air will be to here. This is an AND valve, so we also have to have another thing true, and that thing would be that 1.4 would be true. 1.4 is that the double acting cylinder is in the retracted position. So if the double acting cylinder is in the retracted position and then we hit the push button, then air will come up here to this 5.2 and cause air to go like this and cause this to extend. Okay, once it extends, then obviously let's do blue, then this signal would no longer be true, right? Which means that this signal will no longer be true, and that signal has then disappeared. Then we hit 1.3, so that means that air will then travel up through this limit switch, come to here, but now we got an on delay timer, right? So the on delay timer takes time to build up pressure in the tank. Once the pressure is greater than the spring, then this will move over, so air will eventually go to here, push this over, and then air will come up here and come to this side of the 5.2. We eliminated this signal in that 1.4 was no longer true because it was no longer in the retracted position. So once the timer goes times out, then this signal will come in. That corresponds to this side of our 5.2. So air will then come up here and cause this guy to retract. And any air that was in the double acting cylinder will exhaust out of port number 5 there. Okay, so logic for this guy is that push button is pressed and the double acting cylinder is in the retracted position. That will cause the 5.2 to change state. This will extend slowly. Once it extends slowly to 1.3, then this limit switch will be tripped. That will start this on delay timer, build up pressure in the tank. Once the pressure exceeds the spring, then this will move over, and then air will be able to come over here to the 5.2, causing the double acting cylinder to retract. Okay, so that's the first time that we've seen our timer there. So again, I'll ask you whether it's an on or off delay timer. Okay, so hopefully everything worked out for example number 9. Let's look at example number 10, guys. So example number 10 was our lab number 17 that we did in class. Can I get all this on the screen here? 2 seconds. No, that's frustrating. Okay, so for this guy, we have the drill and the clamp. Both of these guys are drawn with a martini glass like this, right? So in terms of speed control, then this is our extend speed control. This is our retract speed control. This is our extend signal. This is our retract signal. B0 is the drill retracted. Okay, B1 is the drill extended. A0 is the clamp. Where's A0? A0 is the clamp retracted. And A1 is the clamp extended. Okay, this was retract, extend, extend limit switches. So when you were doing this in the shop, you had to be careful of a number of things, right? Like I drew on the cylinders, drill and clamp, so you were actually using the appropriate cylinders, and you had to make sure that the limit switches A0 and A1 were the ones that corresponded to the clamp, and the B0 and B1 were the ones that corresponded to the drill. The other thing that messed you up was that on this diagram, the clamp and the drill are pointing to the right hand side, whereas on our trainers, the clamp and the drill are actually pointing to the left hand side, which would have changed your components for 2 and 4 to each of those units there. Okay, there is one 5-2 limit switch here. So those of you guys online who are seeing this for the first time, this one's quite complicated. And if you mess this up, like actually connecting it, it's quite really hard to troubleshoot. But that 5-2 that's in the center there, that's going to go between 2 different bus bars. So I'm calling about bus in that electrically we have bus bars that allow power to go to different portions. But you can see here that when this side of the 5-2 is true, then all of these components are being fed by this bus. So by bus, I'm just meaning that like that supply is feeding all of those guys. Okay, when the other side of that 5-2 is true, then it feeds the other bus, so the other power system, to all these different components here. Okay, so this one's super cool in that it's got this 5-2 that bounces power back and forth between different components in the circuit there. Come on. Okay, so we want to make sure that that one's that we connect everything properly there. For this one, we would need to have 5 T's in order for this to work properly. So the sequence of events for this guy, those of you who are in my class, you guys already know the sequence, in that the push button has to be pressed and A0, the clamp has to be in the retracted position. Okay, at that point, we're then going to have air going to here, right? So if both of these guys are true, then air will be applied to this unit. That means that this side of the 5-2 will be true, and the blue side of the logic will be true. So let's actually do that signal in blue, right? So those guys are good. That signal comes in, and so the blue side is then actuated. Okay, at that point, we will have air coming to here, right, which will cause the clamp to extend. There's no speed control in the clamp, so the clamp extends quickly. So clamp goes out first, right, hits A1, and then once A1 is tripped, that's off the same power rail, right? So then air would be able to come to here, which will cause this to be true, which will cause the drill to extend, but the drill is going to extend slowly. Okay, once the drill extends, then it's going to hit B1, and once B1 is tripped, okay, so that is fed from the same power source, then air is going to come to here and feed into this side of the 5-2. So this will be true, and we have to see whether this side has actually been eliminated. Well, the push button is no longer pressed, so that isn't true. The clamp is no longer in the retracted position, so definitely this side is false, allowing for this side to come in. Okay, so once the drill extends, it hits B1 and then changes the power rail to the red supply now. So now air is available on the red supply line there. The red supply line then goes to all of our different components. So that feeds over here to the start, but the start is not pressed. So where else does it go? It comes over here and comes to this side of the drill, right? So at that point, we have the drill signal coming in, right? So the drill is then going to retract, right? So this guy is true. If you're wondering, like on this side, and that's why I paused there, because we want to make sure that that signal is gone, right? That signal is gone because we're on the red power rail right now. So the clamp is definitely extended, right? But the power rail, or where the air is being supplied, is on this rail right here, not on the blue rail. So the clamp is definitely extended, but there is no air being applied to A1. So that means that this signal can come in, cause the drill to retract. So the next thing is that the drill is going to retract, again slowly because we have speed control there. And as the drill retracts, then B0 would then be tripped. B0 is fed from the same bus bar, so that will allow air to come to here. Again, the blue side is eliminated, so that means that this signal can come in, which will cause our clamp to retract, and it's going to retract as fast as possible because it doesn't have any speed control there. Cool, so this is our drill and clamp circuit. It's a little bit different in that you can see that the supply is drawn to all the components on the bottom here. Supply here. So we have 3 supplies there, and that's just so that we don't have lines crossing all over the place. And you'll see that the 3 2s are mounted in different positions throughout the circuit there, rather than a line on the bottom. So sequence of events here is that the clamp goes out, clamps there our piece of wood, right? Then the drill goes out slowly, drills out the dowels, comes back slowly, so we're not ripping and tearing the wood. And then once the drill has drilled out the dowels, then the clamp then releases and waits for us to put in a new piece of wood and then hit the start push button, right? The start push button is a foot valve, so we're putting the wood in with our hands and then pressing down on the foot valve to clamp the component there. Okay, so hopefully everybody's cool on example number 10. So if you've done this one in class, that one was fairly simple. If you're looking online at this one, you can see that we're getting increasingly complicated in the circuits here. So again, for the test, this is going to be like near the back end of the test, where it's getting increasingly harder and you were cursing me and my family 3 generations back. Okay, then we've got example number 11. I think this is the one that I left you guys to do on your own. Okay, let's walk through this guy. How much time? This video is quite long, so hopefully you're with me all the way through this video, or you've sped up the timing on this one. Okay, so we got 1S1 for a push button. We've got a retract limit switch. We've got extend limit switches here. We've got our signals, extend and retract. So normally we start off with speed control. So this will be an extend speed control, right? It's in the retracted line, so it's going to be the extend speed control. This one will also be an extend speed control because they're drawn with the martini glass like this, and it's in the opposing line. Okay, then we'll draw in the names of our components here. So 1B1 is this guy right here. It looks like it's actuated right now, so you can see that it's actuated in that 1A1, the double acting cylinder, is shown to be in the rest state or in the retracted state at the moment. So that is 1A1 in the retracted position. Okay, 1B2 is 1A1 in the extended position. 2B1, where's 2B1? 2B1 is up here, so 2B1 is 2A1 in the retracted position, and then 2B2 is 2A1, right? I'm getting 2A1 from here in the extended position. Okay, let's take a look at our logic. So we'll start out, usually we start off with red for the logic for their first portion. So we have 1S1, the push button being pressed, air will come up. This is a series circuit, so as long as 1S1 is pressed, the push button is pressed, and 2A1 is in the retracted position, so as long as that double acting cylinder is in the retracted position, then air will come up here, actuate this 5-2, that is this side of the 5-2, so then air will come up and cause 1A1 to extend. So our first thing is that 1A1 is going to go out. It's going to go out slowly, right? Because it has speed control in this line. Okay, once it goes out, then 1B2 is then going to be tripped. So 1B2 is right here. Okay, so and keep in mind that no, we haven't done anything. Yeah, no, we haven't done anything with this guy yet. So this is still true, right? Okay, so then I lost myself. 1A1 then extended, right? So 1B2 is then tripped. So 1B2 has air going to here. That corresponds to this side of the 5-2, which means that air supplied to terminal number 1 is going to come up here to 4 and extend 2A1. And we have speed control there, so the next thing that's going to happen is that 2A1 is going to extend, and again it's going to extend slowly. Okay, once that goes out, then we've got to 2B2. So 2B2 is then true. This is now false, right? So 2B1 is now false, right? So that means that this signal has been eliminated, okay, and no air is there. Okay, so now we've got 2B2, which is true. Where is 2B2? 2B2 is here. That means that air comes up to here, comes through this guy, and pushes back on this 5-2. This signal was eliminated, so this signal can then come in. That means that air from the supply then comes up here and causes this guy to retract. So the next thing is that we have 1A1 retracting, and it's retracting at full speed. Okay, once 1A1 retracts, then the next thing is that 1B1 is going to be true. We can say that 1B2 is no longer true, right? So 1B2 is no longer extended. Okay, so we've got 1A1 retracted, right? So then 1B1 is then true. So if 1B1 is then true, then air will be able to come up to here. We eliminated this signal right here, so this signal can come in. Let's do another color for that, because that was our next sequence there. So this is true, which corresponds to this side of the 5-2. So then air will be able to come up and cause this guy to retract. So the last thing is that 2A1 is going to retract at full speed. Okay, so this is this, if we do 1A1 as A, and we do 2A1 as B, then that is the similar to, I think, lab number 16, right? A goes out, then B goes out, then A comes back, then B comes back, right? So in this case, we press the push button. The double acting cylinder 2A1 has to be in the retracted position. That signal will come in, cause 1A1 to extend. Once 1A1 extends, then 1B2 is tripped, which sends a signal to here, which causes 2A1 to extend. Once 2A1 extends, then 2B2 is then tripped, which sends a signal into this guy, which causes 1A1 to retract. Once 1A1 retracts, 1B1 is true, which causes a signal to come into this 5-2, which causes 2A1 to retract. So 1A1 goes out, then 2A1 goes out, then 1A1 retracts, then 2A1 retracts. Okay, hopefully everybody's cool on the sequence of events for example number 11. I believe this was the one that I left you guys to figure out, so hopefully you were able to figure that out. Similar, exactly the same as lab number 16 that we did in class, guys. Okay, last one, guys. Okay, this one is difficult. Let me zoom in here. Let's see if we can get all of our, we get this toit. Okay, that might be the best I can do. Can I grab this one more time? Yeah, okay, sweet. Okay, so I'm just gonna draw this timer the way that it should be. So this would be into this unit. There would be a T, and then the tank would be up here. Okay, this one's really hard to make out, but the martini glass is drawn like this. So this one's an on delay timer, but this is only going to take 5 milliseconds. So basically, as soon as the signal comes in, then it trips that timer there. The name for this circuit is an anti-tie-down circuit. Okay, so I'm not sure if you guys have talked about this in shop. An anti-tie-down circuit would be one where you have to hit both push buttons for the press to come down. So you're not able to physically tie down one of the push buttons and have it active and then just press the one push button. You have to press both push buttons, and they both have to be pressed at the same time or within 5 milliseconds of each other in order for the press to actually extend down. Okay, so obviously we're not going to use this circuit to do an anti-tie-down circuit. Anti-tie-down circuits can be purchased with electronic timers. You have push buttons on either side, and they don't allow either of the push buttons to be tied down, and that means that both have to be pressed simultaneously, which means that the operator's hands will be pressing the push buttons and will be in no danger of being crushed by the press, because there's no way that they can place the component in there and just press one push button. It's not going to work, right? And then out in the field with larger presses and stuff, the operator could be wearing like a vest with like airplane cable that actually pulls them back. So when they press the push buttons, it pulls them back and they're in no jeopardy of falling into the machine. Okay, so let's take a look at this circuit, guys. We got a little bit of logic here. We got an AND logic here. We got an AND here. We got an OR here. Okay, and we've got supplies. So you can see that the supply is drawn here, 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 and here. So in all the other diagrams, the supply was drawn as a triangle. Here it's being drawn as a circle. And that way we don't have lines crossing on the diagram. Okay, let's take a look at our sequence of events here. We're going to back engineer this. So for this to actually extend, that means that this air would have to go up here, right? Which means that this side of this 5-2 would have to be active. In order for that side to be active, then we would have to have a signal into here, which means that air would have to come up through here, which means that this would be where the air came from, which means that no signal would be coming into this side. Air would be coming from here, from this T, and it would have to be coming from this AND valve, which we'll get to in 2 seconds. It also comes over here. No, actually, let's deal with this AND valve right now. So that means that air would have to be going to this guy, up through here, right, over to here. So this signal would be true. That means that no air will be on this side, which makes sense. If we don't have air here, we wouldn't have air here. And we'd also need air from here, and that comes from this AND valve, which means that both push buttons would have to be pressed, right? This guy would have to be pressed in order for air to come up here, and this guy would have to be pressed as well. Okay, so that's our sequence for having the press actually come down and punch whatever component that we're working on. Okay, so that's the way that I would deal with more complicated circuits. I would look at the actuator and then reverse engineer it to see what things need to happen in order for it to extend. Okay, so hopefully everybody's cool there that this push button and this push button have to be pressed in order for air to come to here. This component right here cannot have air being applied to this side. That would mean that air would be able to come up here, over to here, up to here, and actuate that unit there. Okay, at the same time, we would also have air coming to here, right, which comes over to this side, right? So this signal is true, which means that this guy is true. So that means that air is then blocked right here. So that means that no air gets to this component right here, which means that no air is going to get to either of these lines here. Okay, so that's key, because if we look at the other side of the circuit with those push buttons, then if we press one or the other push button, then watch what happens. One push button is pressed, that ball moves over to this side, air comes up to here, fills up this tank, and within 5 milliseconds, then this guy is going to be true, right? So it looks like with either push button, right, this guy could be pressed as well, this ball would move over, air would move over to here, within 5 seconds the tank would be full, and again it would actuate this side of that 3-2 pneumatically operated valve. So the timer is always going to time out any time that we put either of the push buttons. If we press both push buttons at the same time, then the press will extend. Once the press extends, we have pressed one push button or the other. So the timer is going to time out every single time that we initiate this circuit here. Okay? That's key because if we eliminate, so wait, hopefully everybody's cool so far. So let's stop here and make sure that everybody's cool so far and that the timer is tripped. The double acting cylinder has extended, right? But we have this back fed right here, so there's no air applied here. So this unit has moved over, but there's no air available on any of these lines because we press both push buttons at the same time. Okay, now watch what happens if I let go of one of the push buttons. That means that this signal, so I'm going to let go of that push button right there, that signal right there is eliminated, which means that this guy is eliminated, right? Which means that this guy is eliminated, right? So that signal is no longer there, which means that this is no longer true. All of a sudden, we have this side of that 3-2 now active. Air comes up here, right? Now I've got air in this line. Let me do that in a little bit darker color. So air is now available here. Okay, this has been actuated, so air then comes up through here and then comes to either one of these guys. As soon as that comes to this one, then air was eliminated from here anyways, but the air is stopped on this unit, so now this 5-2 goes to its rest state and causes the press to retract there. Okay, that's also going to bring air over to here, right? Which means that this is true, which means that this is blocking the air to this point right here. So we blocked air in two different positions, causing that press to then retract. So in this case, it's an anti-tie down circuit in that both push buttons have to be pressed at the same time, right? So this push button and this push button have to be pressed. That sends signals up to here. The timer is going to time out within 5 milliseconds, but within that 5 milliseconds, this air has already come over to here, tripped this, and blocked the air to these two lines here, which means that air was able to come up and extend the press and have it punch whatever material that we're working on. Okay? Once we've pressed either of the push buttons, the timer timed out, so if we stop pressing one of the push buttons and only have one pressed, then all of a sudden this is no longer true, this is no longer true, which means that this is no longer true. The timer has already timed out, so air is applied to these two components, which blocks air to this 5-2, which brings this to a rest state with our spring, which causes immediately for the press to retract. Okay, so this one, for me, is disgustingly hard. So this is probably as difficult as the test is going to be at the back end of the test. Again, probably 30% of the test is going to be this hard. Keep in mind that we built up marks all the way along and built up confidence, only to be crushed at the back end here by really hard questions. But we're going to have 2 or 3 questions at the back end of the test that'll be something similar to this, in that it's not intuitive and there's some funky things going on in the circuits, and you'll have to find either sequence of events like this, right, or you're looking at components like this in an anti-tie down circuit. Okay guys, that's everything for the review. Hopefully you found this helpful. Hopefully you feel confident for the test next week. those of you guys online, you can put any comments below. I'll have to find a way to share this PDF with you, so I'll have to put this onto a website or something like that. So once I publish the video, then I'll also have the PDF available for you guys to download. And if you're doing this at home, it will have, again, the questions, right? So it'll have a blank sheet here, and then it'll have an answer on the next page there. All right, guys, thanks very much for your patience, and I'll see you guys on the next video.